Hi guys, my name is Ernest, and this is Ernest Sciences and Mathematics TV channel. Today we're going to look at one of the procedure that we can use, or rather number of procedures that we can use to achieve this class of organic compound that we refer to as carboxylic acid. Now, carboxylic acid fall under the category of organic compounds that we refer to as carbonyl compounds. And we have illustrated in some of our videos that this basically is a compound that consists of carbon that has been attached to oxygen using that double bond. And therefore, from this, we're going to use various examples that are going to assist us, of course, try to illustrate how we can be able to achieve this class of organic compound that we refer to as carboxylic acid. We had earlier mentioned on that in order for us to appreciate these specific types of compounds, it's good for us to try and find out a connection that they have to our day-to-day applications. And therefore, for this case, for carboxylic compounds, these are compounds which appear and are very common in our day-to-day applications. For instance, if I mention about the concept of vinegar, then therefore, this is going to contain what we call acetic acid, which of course we are familiar with this as one of the essential compounds that we use in our day-to-day application. So therefore, next we're going to see that in the pharmaceutical industry, we have aspirin, which is a drug. And this, of course, is going to contain what we refer to as acetylsalicylic acid. I've written those spellings correctly. So in the pharmaceutical industry, we're going to see this carboxylic acid compound being used widely. And also in some of the supplements like vitamin C that we normally take as a supplement in our foods, this is going to contain what we call ascorbic acid, which is of course a carbonyl compound, which is fall under the category of carboxylic acids. And perhaps if I can give a final one, like oxalic acid that is found in spinach, which is daily consumption for vegetables, and therefore it's going to play a vital role in acting as one of the requirements that we use in our day-to-day life. So mentioning a few, these are some of the uses of the carboxylic acid or the application that we find in our day-to-day life. And therefore it's of essence for us to try and find out how we can be able to synthesize this class of organic compound. So therefore I'm going to give a number of procedures that we can use to, of course, achieve this final product for carboxylic acid. And one of them is a transformation from alcohols, just give this, alcohols and aldehydes through a process that we refer to as oxidation. We've looked at some of the areas where this specific application of oxidation, which is an organic reaction, has been applied. So in this case, we're going to use the chromate ions, which are going to assist us in trying to achieve this process of oxidation. So therefore, as I've mentioned, we're going to subject this particular compound of an alcohol to oxidation using, just use this space. So therefore, we're going to have this alcohol being subjected to oxidation in order to achieve this class of organic compound that we have referred to as carboxylic acid. So therefore, we're going to have this one being represented as this. So I've forgotten to mention the general representation, but basically this one is a general representation for carboxylic acid with a carbonyl carbon with a OH at this specific point. So therefore, we're going to use this one, as I said, an oxidizing agent to achieve this specific goal. So basically for alcohols, I can just use this other side to illustrate. For ketones, I can just use that one. So therefore, oxidation of that specific aldehyde is going to assist us achieve this final product at the middle that is referred to as an alcohol. Of course, we have looked at a similar reaction mechanism for such a kind of a reaction, and I'm not going to, of course, engage in that detailed explanation for that. So this is the first procedure that we're going to use oxidation of alcohols and aldehydes respectively in order to achieve this final product what we call carboxylic acid. So next we're going to look at the oxidative cleavage of unsaturated compounds, which basically are alkenes and alkynes. And in this specific case, we're going to use alkenes in order to illustrate that specific example. So suppose we have this specific double bond compound. So we're having that one for R prime or R1 and R2 to differentiate that. So we're going to have this one. So we're going to use potassium permanganate in order to achieve that specific result. And this is going to result in the formation of our two products, whereby we're going to have a carboxylic acid at this specific point, and then we're going to have a ketone being formed at that specific point. We have looked at the concept of course, which is not related to this, of a Markovnikov, not Markovnikov really, but products which are formed and they will always have a preference insofar as their characteristics are concerned, and we're going to look at that one in a different video. And in some areas we're going to require specific reagents in order to come up with specific reagents in order to come up with a specific product. But in this case, of course, this is one of the ways that can assist us achieve a carboxylic acid, which is represented as such. And next, of course, we can use another procedure that is, of course, oxidation of alkyl benzenes. And these are substituted benzenes that we had looked at in one of our videos on the structure of benzene and its derivatives. So in this case, I'm going to use methyl benzene. If we have a benzene which is substituted, this is just use this. So if we have a methyl benzene that is substituted, we're going to illustrate this one like that. So this one is going to undergo oxidation, and in this case we are also still going to use potassium permanganate, and that is going to assist us to achieve this specific product of carboxylic acid that is going to be represented, of course, using this specific product. So this is one of the ways in which we are going to achieve what we refer to as carboxylic acid. And as I said, I'm going to use an illustration from another video to show the reaction mechanism. And this is number 3. So the last one, of course, we are going to use what we call the Grignard's reagent via carboxylation. And this is going to involve the CO2 or carbon dioxide, an acidic condition. Of course, we can just give a summary of this specific reaction, where we are having this Grignard's reagent that is undergoing, of course, carboxylation, and we said this is an acidic, and this is going to relate to the formation of a carboxylic acid that can be generally represented as such. So therefore, this among other methods we're going to see are going to assist us achieve this class of organic compound that we have referred to as carboxylic acids. So of course, we have already tackled other compounds, but in our next discussion, we're going to look at other methods that I've mentioned, of course, which basically did not entail the use of these 4 examples, which of course are going to be supplementing on how we can be able to achieve this class of organic compounds. So kindly check on our comment section and engage us in the comment section, and check on the description boxes for other organic chemistry topics and other related videos. So that is for now, guys. Bye. God bless you.